Hi, my name is Katroth Rajesh. My roll number is 2978156, branch aeronautical engineering, and my subject is optimizing avionic performance through reconfiguration computer architectures. So here we discuss about the introduction. The aviation industry is constantly seeking ways to enhance avionics performance. Comfortably, computer architectures offers a solution to optimize performance and adapt to evolved requirements. This presentation explores the benefits and challenges of implementing reconfiguration computer architectures in avionics. Avionics performance challenges. Here, in the traditional avionics systems face challenges in the meeting meeting in the increasing demands for computational power and flexibility. These limitations hinders the ability to adapt to new technologies and requirements. Reconfigurable computer architectures present a opportunity to address these challenges and enhance avionics performance. Understanding reconfigurable computing involves the use of field programmable gate and arrays and is also known as FPGAs and the programmable logic devices, and this is known as PLDs, to create adaptable computing platform. These platforms can be reprogrammed to perform specific tasks, offering flexibility and performance optimization in avionics applications. And benefits of reconfigurable architectures. Reconfigurable computers architectures enable real-time adaptability, power efficiency, and fault tolerance in avionics systems. They also facilitate rapid prototype and hardware acceleration, enhancing overall performance and reducing development time. While, while reconfigurable architectures offer significant advantages, their implementation in avionics systems introduce challenges such as verification and validation, security, and integration complexity. Addressing these challenges is crucial for successful deployment. Case studies. Several successful case studies demonstrate the effectiveness of reconfigurable computer architectures in enhancing avionics performance. These studies showcase the benefits of dynamic reconfiguration, adaptive processing, and fault tolerance in real-world avionics applications. Future trends. The future of avionics points towards increased adoption of reconfigurable computer architectures, advancement in machine learning and artificial intelligence, and sensor fusion will drive the need for the more adaptable and high performance avionics systems. Regulation consideration. The integration of reconfigurable computer architectures in avionics necessitate careful consideration of safety standards, certification process, and compliance requirements. Collaboration between industry stakeholders and regula- regulatory bodies is essential to ensure a safe and reliable implementations. Implementation best practices. Successful implementation of reconfigurable computer architectures in avionics required adherence to best practice in design, testing, and deployment. Emphasizing reliability, safety, and performance optimization is crucial for achieving successful outcomes. And finally, the conclusion. Reconfigurable computer architectures offers a promising avenue for optimizing avionics performance, while challenging exists the benefits of flexibility, adaptability, and performance enhancing make reconfigurable architectures compelling choice for the future of avionics. Thanks.